What is our last class?
It's like
Hmm?
types of data collection and descriptive statistics and measure of central tendency.
So far we will just spend some time understanding that measure of central tendency. What is the use of measure of central tendency? What we are measuring?
It describes central data,
So yes,
like
it's a
mean, average.
Hmm.
Yeah, main median mode.
Hmm. Okay.
Mhm.
Now, now the second point within that same module number 2 itself. Okay. So this next concept is it's a sub concept, second module itself. Okay. So why it is too much big? Okay, cool. Even if you are facing, in terms of UI, okay. I mean, UI means user interface. If you are unable to see the proper things, then what we can do, you can raise it actually, because you are the ultimately user for this one, right? Am I right or not? Okay.
Mhm.
So yeah. And the second next concept is, it's a measure of dispersion. What is measure of dispersion? That means spread. How the data is spreading around the mean and all. Okay, how the data is distributed. That we can measure with the help of various concepts. Okay, we can describe it. Tell me. See, when I'm talking about measure of dispersion, that means it is tell that how data is spreading, how the data what we have it, how it is spreading, that we can measure with the help of measure of dispersion. For finding these things, for measure of dispersion, we do have various statistical concepts we can use it. The first one is the range. Okay. So in generally, you might be thinking like, right, for example, in your company, there are lakhs of employees are working. Okay. What is the range of salary? So have you heard about this name ever? Have you heard this kind of question? What is the range of this particular salary, or else what is the range of the score? What is the range of qualification of that particular exam and all? Have you seen that particular thing or not? Hmm?
Yeah.
Or else what is the max that means, if you're conducting one particular exam, okay, some of the students are getting some score, some of the students have got some score, right? So range means what? The range between minimum and maximum, right? That we can simply say that it's a range. Okay. For example, you have some sample 1, 2, 3, 4, and there are 5 samples of them. Okay, one student they got 70, and one student they got 80, one student they got 45, and one student they got something 50, and one student they got 95. If I ask what is the min and max, what is the max? It's a range is of 45 and max is 95.
No.
So if I ask the question, what is the range of score you got in your class, then you can say, in my class, they got the range between 45 to 95. They got it right. This kind of answer in general you can share it. Am I wrong or not? Hmm? Okay. So range means a very simple thing. It's a kind of it's a just simply it's a difference between it's a it's a difference between minimum, sorry, maximum and minimum. So if asked the question, what is the range of the what is the range for this particular sample or this particular data, then what we can do? You can do the difference between these two things. For example, 95 minus 45, then we are getting the 50 over here, right? Clear? So this is exactly the range of it. Clear or not?
Yes.
I hope you
Yeah, clear.
understood what is mean that range. Okay. Now the second metric, which is variance. The second metric is variance. What exactly the variance is doing? And so it is the average squared deviation from the mean. Average squared deviation. Deviation means what? How which is variating with the mean actually. For example, it's simply just 1 second, guys. I hope you understood exactly the difference between what exactly the range, right? Now we'll talk about variation. Variation means I already shared with you average square deviation, okay? Or else you can simply say that average square difference from deviation or difference from the mean, from the mean, that we can say it's a variance. In generally, the formula for the variance is so sum of it's your data point minus this is a mean, okay? It's a squared average squared, right? Average squared means what? It's average means doing some, and n means total number of points. N means what? It's a total number of data points, okay? And so in generally, if we have some values and all, so 1 to n, okay? xi2, it's a population mean. So we average squared deviation or difference from the mean. So this is your data point and this is your mean. So average squared difference from the mean, right? So this is exactly the variance it is. Okay. And so with help of this one, we can identify how data is variation or deviation from the mean, that you can simply identify. Okay. And next data points or next metric is standard deviation. So standard deviation. See, because of the square term, even we have small value or even we have the small difference between your data point and mean. So because of this particular square, it shows too much large. You feel that there is a lot of variance is there between your data point and your mean, right? So because of the square term you added. So for to handle this kind of thing, then what we can do actually, we're just applying the square root of the variance. Square root of variance. When we are applying the square root of the variance, okay, and it tells how much data is deviating from the mean exactly. Okay, simply this is your standard deviation. Okay, so this is your variance, square root of a variance, so that you're getting the standard deviation. Clear? Okay. Are you getting my points and all? I'm mentioning that the formulas and all. Okay, range means it's a difference between max and min. So simply we can say that max minus min. This is the formula for the range. And variance means how data is varying from the mean. So for that one we can use the variance, but the problem, we can use the standard deviation for variation also, but the difference between these two things, and when because of this square root term, the variance, it will be, even it is a small, it will be show at too much large. Okay, for example, and you have a very small amount, it's a very small 0.01, okay, or else 0.5. So if you do the square term, then what we are getting 0.025, right? 0.25, right? It definitely it could be the small, right? That means if your difference is less than the 1, okay, and it will be showing you, okay, it will be showing you something like, it is a small, but it will be showing you a very small variation, okay. But because of the same square term, if it is more than the 1, even it is a small difference is there, because of the square term it will be increased. For example, the 10 is your difference, then if you do the square term, then it will be the 100, right? If you compare these two things, it's a definitely large. Am I right or not? Okay. So that's the reason we, instead of using the variance for deviations and all, for variance on for showing the deviation with your data point, the good term is that the good practice is the standard deviation. Standard deviation, it's a very simple that you have to apply the square root on top of your variance. Okay. And the next concept is interquartile range, IQR. Okay. See, interquartile range means, even you have thousands of samples are there. Sample, you mean you already know that it's a subset of your data set. You have 1,000 data points. But what we are doing actually, if you want to calculate the interquartile range, it's a range of the middle 50%. It's a range of middle 50% of the data. That exactly the interquartile range. So range and interquartile range is both are same, but the see what happened in case of range, you might have the minimum and you have the maximum. You are doing the difference between these two things. But whenever I'm doing that, interquartile range, we are taking that middle 50% of the data. That means you're not considering the minimum, you're not considering the maximum. Okay, between the min and maximum, you have to be get it the 50% of middle of the data. From that one, we are doing that, the difference we are applying the range of it. Clear? So that means what I'm doing actually, my 100 samples, I'm splitting into 5 data points. It's a Q0, quartile 0. This is Q4, quartile 4, Q1, and this is Q3, and this is a Q4. If I said this, if I said the 50 percentile of the data, we can consider only this range, right? Q3 and Q4. If I apply the range, then what we will get? Q3 minus Q1. Q3 means it's a quartile, guys. See, even you have the thousands of samples are there. This thousands or 10,000s or 1 lakh of samples that we are converting into the 5 elements that we can call it as the 5 summary data. 5 summary data. That means whatever the data point we have it, that all the data points we are converting into the 5 data points. That 5 data points are Q0, Q4, and Q1, Q sorry, sorry guys, Q0, Q1, Q2, Q3, Q4. Okay, this Q0 is your maximum. So I can tell you what is Q0. It's your minimum, and what is your Q4? This is your max. Okay, and this is middle value. Exactly, it's a median. Okay, median. Simply, I can say it's a median. Okay, so this value we can say that it's a quartile one. That means 50 percentile of the data, and this is 70 percentile of the data. Okay, that is your Q3. This is 0 percentile. This is 50 percentile of the data, and this is 100 percentile of the data. So if whatever the data sample, if you consider 0% means it's your minimum value, 100% means your maximum value, 50% means middle value, 25% in the sense first quartile, and 75% means it's a third quartile. You got it?
Yes.
We can give you one more example. I have the data is 10, 20, 30, and 40, 50, 60, 70, 80, and 90, and 100. Okay. I have total how many samples? There are 10 samples, right? And from this one, what is the Q0?
Okay.
Q0 is the 10, and Q4 is 100. Okay. I can take it this 5 elements. This is my Q0. This is my Q4. This is 10. This is 100. Okay. And this is your middle value, median value. Tell me what is the median value?
50.
So median means middle two terms average. If it is the even number of elements, middle two terms average. So 50 and 60, what is the middle value? 50
55.
plus 60 by 2, it's a
55.
55. Okay. And this is Q1 and this is Q3. Q1 means it's a 20 percentile of the data. So if you consider this one, then what is the middle value? What is it's 2035, it's a 25, right? It's a, and what about this one? 75, right? Okay. So the difference between these two things are, it's your interquartile range. 75 minus 25, it's your 50. Clear? So even you have thousands or 10,000, 1 lakh of elements, we are rounding off as a 5 elements. So that is the reason we can call it as the 5 summary data. Okay. So we have one more metric is there that we can call it as the mean absolute see deviation. This is optional. So either we can use the variance for how the data is spreading. We can use the standard deviation and how the data is spreading. And we have another metric, which is mean absolute deviation. So we are not, doing the squared and square terms. We're just implementing something like that, sum of, okay. So you're just applying the modulus. Modulus means even if you have the negative numbers, that we can
So the positive.
make it as a positive. Okay. Then we are doing the sum of it, right? So it's never be 0. Okay. So this is how we can say absolute mean absolute deviation. So if it is the n number of sample, then it's n. Okay. The sum. Okay. Clear, right? I hope you understood. So this particular things will do practically how we can how we can see that, how we can apply the Python on top of this particular data and all. Have you noted this particular points? Range, variance, standard deviation, mean absolute deviation. I explain only 4 matrices so far.
Yeah. So Anjan, in the quartiles, right? Why we took only 2 values for the Q1 and Q3?
I said, we have 5 summary data. I told you, right? 5 summary data.
Correct.
Okay. So 5 summary data in the sense, 5 summary data means whatever the data set we have it, that we can converting into the 5 elements or 5 data
Right.
points. What are the data points? Those first one is Q0 is data point 1, Q1 is data point 2, Q2 is data point 3, Q4 is data point 4, Q5 is Q3 and Q4. Okay, data point 5. So these are the 5 data points. You might be thinking, what is Q0? What is Q1? What is Q2? What is Q3? What is Q4? Okay.
Right.
Q3 is Q0 means it's your minimum value in your data points.
Right.
Q4 means it's your maximum value in your data points.
Mm-hmm.
Q2 means it's your median value, middle value. Okay.
Mm-hmm.
Yeah. Q1 means if you split your data points two parts, if based upon the median, if you split, this is one half and this is another half your data set, right? From the
Mm-hmm.
data set of the lower half, the middle value is your Q1. And if you split your data set with the median value of your main data set, your population data set, you're splitting in a median. Okay, upper half whatever the data we have it, upper split whatever we have it, from that particular entire data, the middle value. Okay, so that we are represented with 25 percentile of the data, and this is 70 percentile of the 70 percentile of whole data. Okay, but actually it's a 50% from the lower half and 50% from the upper half. But when coming to the, if you consider the whole data, and it will be 75, it will be 25 and 75. Got it?
Okay.
We're just
Yeah,
taking 20 percentile means in the lower half, middle value, we can say it's a 25. You have 100 rupees. Okay. And if you split, then lower the 50, upper the 50, right? Okay. Again, from 0 to 50, if I said you like, what is the middle value? That is a 25 only, right? But actually from your 100, 25 is the 20 percentile, 25 percentile. But lower half, that same 25, it's a 50 percentile. Okay.
Yeah.
Got it?
Got it.
Yeah.
Yeah.
Yeah. So simply what I'm trying to tell you, even you have thousands, 10,000, 1 lakh of data points, we are represented with the 5 elements. Whenever you represented with the 5 elements, okay, so that we can call it as the 5 summary data. And with from the 5 summary data, if you do the difference between min and max, that is the range. Okay. If you do the difference between Q3 and Q4, that is interquartile range, because there are 5 quartiles, and from the interquartile range means from the interquartile means you have to remove these two things. Then this from these three, range is max and min, max minus min only, right? Max is Q3, min is Q1 only from this particular scenario. That is the reason from the interquartile. So IQ, interquartile range, the difference between Q3 and the Q1, that we can call it as the interquartile range. Okay. So that is the reason you can easily understand how data is deviating in the middle area, in a 50 percentile of the data. Okay. Clear or not?
Yeah, understood.
Yeah. Let's see practically what we can do. We can try to apply on top of the Python. Let's open my folder. You can see my screen, right? Okay. So in yesterday's session, what we spent for that, no, we are taking that mean median mode, right? Same example, I'm considering it. So simply, and how should I do that? Okay. Or else we can take some new data points, or else we can try to understand. I have a data point, something like that. Okay. And 45, 50, and 55, 60, and 65. This is my data. Okay. If I do that range, if I want to calculate the range value, then what happens? It's max of your data minus, we can have the function is max of your data minus min of your data. Simply, that is your range value. Okay, clear? Now, if you want to calculate the variance, right? If you want to calculate the variance, definitely we should have, we can have a direct function is there. For that one, we don't need to implement that entire logic and all. Okay, you have a numpy. Within the numpy, we can have var function. I have the same data points. Like what I can do, I can able to calculate the variance. var equal to, okay, np dot var, we can, this is the function to calculating the variance. Okay, you just provide your data, then automatically it could be calculating your variance. Okay, so print of var. So this is the variance. When we can take it with all examples, data and data frame. Okay, so let's talk about standard deviation. For calculating the standard deviation, we can have the std. So this particular function we can apply, and this is how we can able to calculating the standard deviation of, see, previously we are getting like 50, right? Now standard deviation it's just 0.707. So this is exactly the standard deviation. So, it is realistic to your data, right? See, your data is 45, 50, 55, 60, and 65. Actually, the spreading is like, five differences is there, right? Okay. But see, because of the variance, we are getting the huge number. Okay. So that is the two huge number. So that's the reason we are using the standard deviation. With help of the standard deviation, we are making like a square root of it. And that's how we are getting this particular data. Okay. And interquartile range, for calculating the interquartile range, whatever the data we have it, first we can calculate at the Q1. So Q0 means I already told you it's our minimum value. min of your data. Okay. And Q1 means what? It's your 25 percentile of the data, right? So that we can have the percentile function is there in numerical Python. Just we can provide your data and we just give you what percentage of the data you wanted. Q2 is your np dot median of your data, 50 percentile of the data. Either you can say that it's a 50 percentile of the data, or else you can apply, we can say it's a np dot percentile of 50 percentage, or else I can take it the same thing in a percentile format only instead of any confusion. Even I can also take it this one also. Okay, so Q0 means it's a 0 percentile of the data. That means your Q4 means it's your 100 percentile of the data. And Q1 means 25 percentage. Q2 is your 50 percentile of the data, exactly middle value. Okay. And Q3 is your third quartile, right? So it's a 70%, 75 percentile of the data. So this is how we can able to calculate. So let's take it calculated the Q1, and let's calculate it the Q0 and Q0 and Q4, what exactly those values. Okay, see. So from your data, so what is the smallest element? 45, right? From your data, what is the max element? It's 65, right? Yes or no? So that is the Q0 and Q4. Now I would like to go for calculating the interquartile range. So IQR in generally, we have a formula is Q3 minus Q1. So this is interquartile range. So with help of interquartile range, we can able to calculate the, we can find the outliers also. How we can find the outliers and all. So definitely we'll see that the importance of the IQR, it could help you for finding the finding the outliers in your data set. Okay. Hello.
Yeah, I understand.
Any questions?
Could you please repeat the last one, how you got 10?
So the difference between 70 percentile of the data and 81 25 percentile of the data. Just simply we can print the Q3
Okay, it's a
and
60. Okay.
Q4, Q1. So 50 is your 60 is your Q3 and 50 is your Q1. The difference between 60 and 50, it's a 10 only, right?
Yeah, I understand. Yeah.
Okay. Now we'll try to go for understanding the skewness. Skewness and cortices. These are the very important terms you might be see most of the time. So I can show you with a graph actually so that you can understand. See, for example, you have a data. You have a data. Okay. The data it was distributed around the mean. So the data it was once if you plot it, you will get the distribution graph, something like this. So can you tell me from this particular graph, have you noticed anything? Is there any skewness? Is there skewness means tilt towards something else, like so most of the data will be rounding into the mean, or instead of the mean, it might be mode or something like that. For example, I can show you positive skew and negative skew. See, something like this. See, if most of the data will be distributed here, and very less amount of this is skewed data, skewed graph. Okay, you might be see this kind of graphs over here. And for example, in some situations, your data it was distributed. Most of the data it was distributed in one particular point actually. So this kind of visualizations or graph, if you see that, that means your data it was skewed. It might be positive skewed or it might be negative skewed. Clear? So if it is a tail, towards right side, then it could be the um, positive skew, and if it is a tail towards left side, then it could be the negative. It's a positive, and it's a negative. Okay. So that is exactly the skewness. With the help of the skewness, the data it was distributed normally or not, then we can able to find out actually. Clear? And next one is cortices. Cortices, it is the data it was distributed normally only. Normally means the data it was distributed equally spreading around the mean. Okay, there is no skewness. The data it was distributed something like this. Okay. So if it is a cortices, there might be a chance of data it was distributed very something like this. Can we call it as a normal distribution? Yes, it's a normal distribution, but thing is that it's there is mm, tiltness is of it, you can easily find that it is a tiltness. It's a it might have most of the outliers are there. Okay, so some situation same normal distribution, it might be something like this. Okay, so this is the kind of thing we can call it as the cortices. It's a high cortices and low cortices actually. So with help of the cortices, we can find that the tailness of the data. Okay, and tailness of your data, that we can easily find out. And with help of skewness, with help of the skewness metric, what we can do, whether the data it could be measures, it you can easily measures the whether it is a symmetry data or asymmetry data. Okay, symmetry data means the data it was distributed normally, that means equally spreading around the mean itself. Okay, mean, median, mode, everything it could be in a zero location itself. Okay, you can Google it, you can easily get it. Here I'm just introducing the 2 points, skewness and cortices. And skewness, which is talking about the data, it was whether it is the symmetry or asymmetry. Symmetric means mean, mode, everything. It could be pointing the same value. Mean and mode and median, everything. It could be in a same area. Okay, same point. Actually, it is pointing same point. But if it is the symmetric or asymmetry, maybe this particular points could be change. It might be positive side, it might be negative side. Okay, clear?
Yes.
So how we can able to calculate it, this skewness and all, we can have a direct formulas are there. Let me share my screen of my Visual Studio Code. I have the data points, right? I have my data point. This is my data set, right? From the data set, what I would like to do, I would like to go with find the skewness, DF of income. You can simply give it like skew. It will give you like some value. Okay, 0 indicating that there is no skewed in our data. Okay, 50, 1 lakh, 50 and non-lakh, right? Most of the data was distributed in a positive way. For example, I'm just changing my data. My data is, for example, it's not 1 lakh some value. Okay, it's very one element is there. So this particular situation, same data we are considering, but it's very huge data is there. If I do, there could be some value was changed or not. Okay, so it is indicating it's a positive skew. Okay, if you plot it, you will know it actually. So how it is distributed and all. Okay, but if the value indicating 0 and the value 0 indicating that there is no skew, it's a symmetric different. Positive indicating it's a positive skew and negative indicating that it's a negative skew, negatively skewed. That is how we can able to calculating the skewness. Okay, meanwhile we can calculate the quartiles as well. And in generally quartiles, it's not more than the 3. Okay, if it is more than the 3, that means your data it was a tilde. Okay, so there is some kind of um, assumption kind of data you do. Okay, so its value is more than the 4, right? That means your data it was tilde. It's some positive peak value you might be getting. Okay, so in generally negative to positive to have it in between -3 to +3, the data indicating that say a quartiles is in the good value. Okay, if it is less than -3 or greater than +3, it could be your tilde is there. Okay, that is how we can calculate the skewness and the quartiles with NumPy and pandas and interquartile range and variance and standard deviation. So in generally, you don't need to calculate these all things and in real time. It's a very basic stuff. It's a prerequisites, I can say. But if you know these things, and then in interview or in somewhere else, if you see that the importance of those things, you can understand actually. Okay, clear? So with help of visualization techniques, now I would like to show you some kind of visual exploration. Coming to the visual exploration, and you have you might have your data itself. I'm going to be using those things, but for importing or for visualization stuff and all, we can use the Seaborn is the one library as SNS. This is one of the library. Okay, and you can have one more library that is matplotlib. Matplotlib.py plot is one package inside of it as a PLT. So these are the two different libraries we can use it for visualization purpose. And so it is indicating there is no Seaborn. Okay, if the package is not there in your environment, then what we can do, we can able to do it pip install on the Jupyter itself. We can do it, or else in terminal also we can install it. Okay, or else in a requirements.txt file we can use it. Okay, I can add Seaborn over here, and after you're adding Seaborn, you can run it. This is the one approach I already show you. And second approach is that directly we can install it on Jupyter Notebook itself. But make sure that we can use this is the character. Okay, special character. You should use it. Whenever you're running this one, then what is mean that you're installing the Seaborn on top of your virtual environment. Okay, requirement is already satisfied. Then why? Yeah. So import is completed, right? So there is no issue and all. Okay. Now I would like to use the SNS because we are importing the name is SNS, and we have this plot is there. With help of this plot, we can find the histogram of those particular thing. So like we can income of it and KDE equal to, and we can give the title is plt dot title. So we can give the title of that particular thing, income distribution, income distribution. And so if you want to display some x-axis and y-axis, and you can do it. Meanwhile, with help of the show method, we can able to see that your graph and all. Okay. So this is your distribution graph. With help of hist plot, we can easily plot it how data it was distributed and all. Okay. Is it clear? So like this, we can use the visualization concepts also, and with help of visualization techniques, we can easily identify. You can easily understand the patterns, and we can detect the outliers, and we can spot trends and all. We can communicate some kind of important things. We can easily findings and all. Okay, so good visuals. It will tell you the story of. Glance and everything actually. So that's what I want to tell you for this particular situation. And for tomorrow's session, what I can do, I would like to be talk about visualization techniques as a model number 4. Okay. So far we have done the 3 models, right? What are the models we done so far? What are the models I covered?
Descriptive statistics, one we covered.
First one is introduction to statistics is one module number 1. Second module is types of
Data
data and
collection.
data collection. And third one is descriptive statistics. I explain you, right? So descriptive statistics concept is completed. And the fourth module I would like to talk, that is data visualization techniques, is the fourth module. After that one, we'll start the probability concepts. Okay. Then we can go ahead with the inferential statistics. Once it is done, then we can go ahead with the hypothesis testing, correlations, and all. We can discuss one after one. Okay. So tomorrow's session is pretty important. We'll go with the data visualization. If data visualization is completed with a short of time, then what we can do? We can go ahead with understanding the probability concepts. So this entire week we can spend understanding the statistics. See, guys, statistics concepts is very important in terms of getting job and all. And but the thing is that because of the technology evaluating and all, then the thing is that we are not using in a practically or in a live environment or in production ready kind of things, because everything is done in a backend itself. But as like a foundation is very important. Like if you know this concepts in future is happen anything, then or else if you want to build your own custom models and all, so this all concepts which could help you at all. Okay, but as a usage perspective in real time, we can't use much these days. Last 4 to 5 years back we are using very heavily, but because of the technology trending and all, then we are not using at all. And everything has been used in a backend itself. Okay, you don't need to worry about these things, how we need to write the code for this thing and all. We don't worry about it. We are not at all using in this level, but it's a basics actually. It's a fundamentals. If you know fundamentals, then no subject wise you might be pretty good. In future, if you want to expose or if you want to explore new technology and all, then you can easily grasp it how that is working and all. Okay.
Okay, sure.
That's for today's session, guys, and I hope everyone is doing good. Thank you so much for your time. Let's continue tomorrow's session with data visualization techniques. Okay.
Okay. Thank you. Good night.
Thanks, Sanjan.
Yeah. Thank you.